Measuring an angle. We have learned to classify the given angles as acute, obtuse, right, reflex, etc. Now we will learn to find their exact measure. This we can do by using a protractor. Measuring an angle using the protractor. Let us measure angle AOB given alongside using protractor. Place the protractor in such a way that the midpoint of its straight edge or zero edge coincides with the vertex O of angle AOB. Adjust the protractor so that ray OB is along the straight edge of the protractor. Out of inner and outer scales of the protractor, read the scale which has the 0-degree mark coinciding with the straight edge, that is, with ray OB. Here read the inner scale where OA touched ray. In this case, the reading is 50 degree. Thus, we write angle AOB equal to 50 degree. Remember, the sum of measures of the corresponding angles on the inner and outer scales of a protractor is 180 degree. Congruent angles. If the measures of two angles are equal, the angles are called congruent angles. In the given figure, angle AOB and angle PQR are congruent angles. Perpendiculars. Perpendicular lines. When two lines are at right angles to each other, or when the angle between two intersecting lines is 90 degree, they are said to be perpendicular lines. In the given figure, lines AB and CD are perpendicular to each other. When line AB is perpendicular to CD, we write it as AB perpendicular to CD. The following are some examples of perpendicular lines. The wall is perpendicular to the floor. Any two adjacent edges of the door or the window are perpendicular to each other. The adjacent sides of a sheet of paper or a postcard are also perpendicular to each other. English alphabet T and L are each made of two perpendicular strokes. Perpendicular bisector. A line segment that is perpendicular to another line segment and also divides it in two equal parts is called perpendicular bisector. In figure alongside, line segment RS bisects, that is divides into two equal parts, line segment PQ. At point O, it means line segment PO equal to line segment OQ. Note, bisect means to divide into two equal parts. Classification of triangles. Classification of triangles on the basis of sides. On the basis of sides, triangles can be classified in the following three types. Equilateral triangle. A triangle whose all three sides are equal is called an equilateral triangle. Here triangle ABC is an equilateral triangle. Isosceles triangle. A triangle having two sides equal is called an isosceles triangle. Here triangle PQR is an isosceles triangle. Scalene triangle. A triangle having no sides equal is called a scalene triangle. Here triangle XYZ is a scalene triangle. Classification of triangles on the basis of angles. Acute angled triangle. If each angle of a triangle is acute, that is less than 90 degree, then the triangle is called an acute angled triangle. Here triangle DEF is an acute angled triangle. Right angled triangle. A triangle in which one of the angles is a right angle, that is 90 degree, is called a right angled triangle. Here triangle AOB is a right angled triangle. Obtuse angled triangle. A triangle in which one of the angles is obtuse, that is more than 90 degree, is called an obtuse angled triangle. Here triangle PQR and triangle LMN are obtuse angled triangles. Relation between sides and angles of a triangle. Each angle of an equilateral triangle measures 60 degree. The angles opposite to equal sides of an isosceles triangle are equal. A scalene triangle has no two angles equal. Altitude of a triangle. A perpendicular drawn from a vertex of a triangle to the base is called the altitude of the triangle. In the given figure, PQR is a triangle and PS is perpendicular to QR. PS is called the altitude of triangle PQR. There can be one perpendicular drawn from each vertex of a triangle. Thus, there are three altitudes in a triangle. Median of a triangle. A line segment drawn from a vertex of a triangle to the midpoint of the base is called the median of the triangle. In the given figure, AD is a line segment which joins the vertex A to the midpoint of line segment BC. Thus, line segment AD is called the median of triangle ABC. There can be one median drawn from each vertex of a triangle. Thus, there are three medians in a triangle.